input function that we were talking about. So what's the input of these functions that we were talking about? Do you remember? She's saying measure of the angle swept. You're saying, what'd you say? Openness, right? So yeah, angle measure. And but that's not going to cut it. We could define 100 different angle measures on a circle. So what? We need to measure the angle swept counterclockwise from the 3 o'clock position. Where's the 3 o'clock position? That's like the positive x-axis, right? Over here on the right side of the circle. So we're going to sweep an angle counterclockwise from the 3 o'clock position. So we need all those details, okay? And then we were going to look at 2 different quantities as kind of output quantities, to locate the position of the bug. And so the first one, what was one of those 2 output quantities is going to help us determine the position of the bug?
Vertical distance of the bug compared to the radius, compared to radius.
Okay, right. So the vertical distance above the horizontal diameter in a fraction of a radius length, right? The vertical distance above the horizontal diameter as a fraction of the radius length. And that's going to give us how high up or down the bug is, right? On the fan. How high up or down. And then this other function we're going to do, the output of another function we're going to do to get is going to be what quantity? Horizontal distance to the right of the vertical diameter, also as a fraction of the radius length. Okay, so for this, where I randomly stopped it right here, I want you to estimate all 3. Estimate the measure of the angle swept counterclockwise from the 3 o'clock position. Estimate the vertical distance above the horizontal diameter as a fraction of the radius length, and the horizontal distance to the right of the vertical diameter as a fraction of the radius length. Go. Estimate all 3. Okay, what do we think here? So estimate for the angle measure in radians. Sai, what do you think? What do you estimate for the angle measure in radians? 2.5. No, in radians. Not sure? What are radians? So we got to have this way of thinking about radians. The number of radians is what? How do we get the number of radians of openness? Brian. Number of radius lengths cut off by the rays. The number of radians of openness is how many radius lengths were cut off by the rays. You got to have that way of thinking. Okay, you got to have that. So how many? If I'm asking what the radian angle measure is, then what I'm asking is how many radius lengths of arc length got cut off, or did the bug sweep out? And what would that be? About what? Not 4.5. 4.8, right? It's much closer to 5 than it is to 4. I gave you these little tick marks, okay? So something like We're calling them estimates. Something like 4.8. Okay, so now, vertical distance above the horizontal diameter as a fraction of the radius length. What do you think? Negative 0.9. Yep, it's negative. And maybe even negative 0.95, right? So it's even. It looks like it's even more than 9/10 of the way down there. But negative 0.9 definitely shows that you know what's up. But we'll just say negative 0.95 because it's almost a full, down there at the bottom, it's almost a full radius length. Okay? Horizontal distance to the right as a fraction of the radius length. Was that Ori? Negative 0.1. What do you think? Negative because? Why negative? To the left. And then 0.1 because? Yeah, that could be about 1/10 of the way over, right? That looks about 1/10 of the way of a full radius. Okay? Does this make sense? So really, this is the basis for this idea right here is much of the basis or the foundation for trig. Okay? So let's take it a step further here. Anybody have a question on this? So here I got similar idea, and we're going to look at breaking it up. So we still imagine that the fan is sweeping continuously, but we're going to focus on one change of angle at a time, of angle measure at a time. So I want you to determine what change of angle measure is this. So they're all equal changes in openness. What change in openness am I illustrating here with this thing? Figure it out with the person next to you. What exact change in openness am I illustrating with this image? Okay, figure it out with the person next to you. Talk. What change in angle measure or change in openness am I illustrating with each point that I'm moving through? Radians, guys, radians. Okay, how many radians are each of those change in angle measure? Hector, what do you think? Pi over 6. Agree with that? You don't? Pi over 8. Oh, we got two conflicting. Which is it? What angle measure in radians is it from the 3 o'clock position to the top of the circle? And what does that number mean, pi over 2? Why is it pi over 2 there? Okay. So find that number on your calculator. What is pi over 2? 0.57 what? 0. One more. 8. 1.5708. What does that number mean? So what is it? So that's a number, 1.508.
How many radians?
Okay, well, what does that mean? What does that mean?
Radius
It
length
goes
takes
one
the
radian
top.
and it goes a little bit more than half of another one.
Right. Okay. And those radians are radius lengths, right? So it's how many radius lengths are 1/4 of a circle, right? How many radius lengths would fit on 1/4 of a circle? So that's the openness in radians. Okay, and then I've divided that up into what? 4, right? 4. So each change in openness or each change in angle measure is exact.
Oh.
Not a decimal approximation. So there was pi over 6 and pi over 8. Which is it? Pi over 8. Pi over 8. 1, 2, 3, 4. 4 equal changes in openness to reach pi over 2. So pi over 8. Pi over 8. What we're going to do now is we're going to look at for equal. Remember we did this with the bottle problems and the walk problem, and we talked about for equal changes in input. We looked at our way of seeing how the output varied. Right. First we asked what does the output do? So if we're looking at the vertical distance above the horizontal diameter, we just say, is it increasing or decreasing? And then we ask, how does each change compare to the previous change? Remember that? Remember all that stuff? So that's what we're going to do. So for equal increases of the input, that's our angle measure. Does the output increase or decrease? Do changes in the output increase or decrease? And then does the rate of change increase or decrease? And then to help with number 2, remember, so sometimes that got tricky. Are those changes really increasing or decreasing? And so we want to ask, do those changes in output become more or less positive or more or less negative in any given situation? So we're going to start with the vertical distance. So here's what we're going to look at. We're going to look at the measure of the angle swept counterclockwise in the 3 o'clock position and the vertical distance above the horizontal diameter as a fraction of the radius length. Okay, and so we are going to take this one step at a time. We're looking at the first quadrant. So in the first quadrant, here's the first increment of pi over 8 radians. And so we asked, did the output to that vertical distance increase or decrease? Did the vertical distance above the horizontal diameter increase or decrease? Increase. It went up. It increased. Okay. But to answer questions 2 and 3, we have to have comparison of changes. So I'm going to do another change. So here's the next change of pi over 8 radians of angle measure. In this second change, did the output, that vertical distance, increase or decrease? It increased again. The amount of increase, so the change in the height, that amount of increase, was it more, less, or the same as the previous increase in vertical distance? Less. Let's do it again. Here's the third change in angle measure. The output in general in this first quadrant, the output is at the vertical distance is increasing or decreasing? Increasing. Changes in the vertical distance, are they increasing or decreasing? Not sure. The height is the vertical distance is clearly increasing. What about the changes in vertical distance?
Decreasing.
Decreasing. Do you see that each change, they're positive changes, getting more or less positive? Getting less positive, right? Each change is getting less positive than the one before. So what about the rate of change here in the first quadrant? Is the rate of change increasing or decreasing?
Decreasing.
Decreasing, because our changes are decreasing. They're getting what? Less positive. The changes are getting less positive, therefore the rate of change is getting less positive. So if we were to sketch this graph, here's what we would see. Change in angle, change in vertical distance. Next change in angle. So this is, our horizontal axis is theta. Angle measure in radians. This vertical axis is our vertical distance above the horizontal diameter as a fraction of the radius length. As a fraction of the radius length. Okay, so what happens is that with each equal increase in angle measure, we get a smaller increase in vertical distance each time. Means that the rate of change is doing what? Decreasing, right? If our changes are decreasing, our change in height decreases, then our vertical distance, then the rate of change is decreasing. And when we said the rate of change is decreasing, the shape of the graph is? If our rate of change is decreasing, then we're concave down, right? Then the shape of the graph is concave down. So what angle are we? What total angle measure are we at right now? Pi over 2, 1.5708 radius lengths to get to the top of the circle. Therefore, 1.508 radians have been swept. Okay, so I want you to go through the same exercise for the second quadrant. I'm going to set it back like this. So now, in the second quadrant, you're gonna say, is the vertical distance increasing or decreasing? Okay? Don't answer now. Work with the person next to you. So is the vertical distance increasing or decreasing in the second quadrant? And then the changes in vertical distance. Are those changes positive or negative? And are they becoming more positive or less positive, or more negative or less negative? Okay? So you're answering questions 1 and 2 for the second quadrant. Ready? Here we go. Watch it again. Here we go. Ready? You can use the same over there on the right. You can use that same So as the angle increases from pi over 2 to pi, does the vertical distance increase or decrease? Question 1. Does the vertical distance increase or decrease? Decreases. From what to what? As a fraction of the radius length, it decreases from what value to what value? It starts at? They're saying it starts at 1. Agree with that? The output. Now the vertical distance. It starts at? Does it start at 1? The input is the angle measure. Now we're asking about the output. The output is the vertical distance. Starts at 1. Okay, it starts at 1. They were right. And then it goes to? At pi, the vertical distance goes to 0. So from 1 to 0, the vertical distance increases or decreases? Decreases from 1 to 0. Now what about the changes? Are the changes negative or positive? These changes in vertical distance, are they negative changes or positive changes? Negative changes. They're getting more negative or less negative? They're getting more. They're bigger negative changes because it's like the reverse of what happened in the first quadrant. Small negative change. So small negative change, a little bit bigger negative change, still bigger negative change, largest negative change is the last one. So are these changes increasing or decreasing if the changes are getting more negative? In or decreasing? In or D? Decreasing. They're getting more negative, right? This was the tricky one. This is the tricky one. But we're going to keep going over and over again. So these are negative changes getting to be larger and larger negative changes. That's a decreasing set of changes. It's counterintuitive because you're saying, oh, the changes are getting longer, right? But they're negative changes. So negative changes that get more negative are actually decreasing changes. So the rate of change is decreasing. Let's watch it. So small negative change, a little bit bigger negative change, still bigger negative change, and here's the largest negative change. So we're getting larger and larger negative changes, which means decreasing changes. And if the changes are decreasing, then the rate of change is? If the changes are decreasing, then the rate of change is? It does the same thing, decreasing. The rate of change is always the same as that's why we spend all this big deal on comparing the changes and asking if the changes are increasing or decreasing. Because the rate of change is the exact same thing. It's always the same. The rate of change will, if the changes are decreasing, the rate of change is decreasing. So all through here, the rate of change is decreasing in the first quadrant, becoming what? Which of these four? The changes are becoming less positive. They're positive changes, but each one is less than the previous. And so if that trend were to continue, what would happen? So then it would change to negative changes, getting more negative. And that's what happens. So now these changes are negative, and they're getting bigger and bigger negative. So that's just a continuation of the trend of the first quadrant. The changes are getting smaller and smaller positive till they hit 0, and then they're getting bigger and bigger negative. So it's just a continuation. So the rate of change is decreasing through that whole top half of the circle. And therefore the graph is concave down for that whole top half of the circle. From 0 to what? Pi. Now we've gone halfway around the circle, so we've extended 3.14159 radius lengths. We're halfway around. Okay. Talk with your neighbor. Next part of the circle. Third quadrant. Yeah.
I didn't.
Okay, what about the vertical distance? Increasing or decreasing? And from what to what? So the vertical distance changes from what to what? Just the vertical distance. So just the output value itself. The output value itself. Increasing or decreasing, and from what to what? I heard decreasing from 0 to -1. Agree with that?
Yes.
Yep, it starts at 0. We're at 0 vertical distance, and it decreases down to -1. Now I can look over here at these changes, right? Are those changes positive or negative? Negative changes, right? Because we're decreasing, so negative changes. Getting more or less negative? Less negative. Changes that get less negative, are they in or decreasing? Changes getting less negative. In or D? In. Increasing. Less negative. If they're getting less negative, you can't just look at the length of them. You have to ask if they're positive or negative. We're getting less negative. Numbers that get less negative are like this. -10, -7, -5, -4. Is that an increasing or decreasing set of numbers? Increasing set of numbers. Yes, the changes in magnitude get shorter. The changes in magnitude shorter, but they're negative changes. And negative changes that get less negative, shorter negative, those are actually increasing. They're moving towards positive, so they're increasing, those changes. Okay, let's see it. So our distance, or vertical distance, is going to decrease from 0 to -1, while the changes get less negative. Biggest negative change there, then a smaller negative change, then a still smaller negative change, then a very small negative change. Means those changes are in or decreasing? Increasing. Increasing. Increasing changes means the rate of change is increasing rate of change. The bug is slowing down. Yes, it's slowing down, but it's slowing down in the negative direction. So it's actually increasing in its rate of change. Let's keep practicing it. Okay. Do the last quadrant. Ready? Go. I'll show it to you. Okay. Does the vertical distance increase or decrease, and from what to what? Just the output itself, the vertical distance. Increase or decrease? Increase from? -1 to 0. The bug is going up, right? The bug is heading up, so its vertical distance is increasing from -1 to 0. The changes, are they positive or negative changes? So first change, second change, third change, fourth change. Are those positive changes or negative changes? Positive. The bug's going up, so each change is a positive change. Getting more or less positive? More positive. It's the easiest one, right? Values that get more positive are increasing or decreasing? Increasing. This one's easy. When the changes are positive, it's easy because it's exactly what you think. You just look at the lengths of them, right? The lengths of the changes. More positive. Getting more positive means increasing. So let's look at how the graph forms here. First positive change, small. Next positive change, a little bit bigger. Then still bigger. Then the largest positive change is the last one. Okay, so all through the second half, the changes are getting less negative and then more positive. So all through that second half, the changes are? No, the changes. Increasing changes. So the rate of change? Increasing. Changes are getting less negative and then continuing that pattern, getting more positive. That's an increasing rate of change. Concave, up. And we're back to starting position, which is what angle? 2 pi. What was it at the bottom of the circle? 1.5 pi, right? Or 3 pi over 2. So the maximum vertical distance in fraction of a radius length is what value? The maximum vertical distance is fraction of the radius length. Is what? And where did that occur? At what angle measure? At pi over 2, our maximum vertical distance is 1 radius length. If you're on the circle, the highest, the most vertical distance you can get is 1 radius length up. And then, what's the very lowest number of radius lengths, or fraction of a radius length we could be? -1. At what angle did that occur? Bottom of the circle. Okay, so this, and so for what circle are we talking about here? So we're talking about the fan, but when we talk about fraction of a radius length, do you see that this applies to any circle, right? This could have been something really small, like a ant going in a circle of a couple millimeters, or this could be a moon rotating around a planet. Would these angle measures change? For really like a astronomically large circle, would the angle measures change? Would these values, vertical distance measured in fraction of a radius, change? No, because you're talking about the fraction of the radius of the circle that you're in. So no matter what circle we apply this to, our values along the x-axis, angle measure, are the same. One rotation, no matter how big the circle, is 2 pi radians. And the maximum number of radius lengths, no matter what circle you're talking about, will be 1. And the minimum number will be -1. So this is a very important, this is a universal relationship for all circles. You get the same set of ordered pairs. You get the same set of points. Angle measure and corresponding vertical distance. That's what all these are just points, right? This is just a set of points. And for every circle with these two quantities, you get the same set of points, the exact same coordinates. So this is a special relationship because it's universal for all circles. Okay, so we have a name for it. So if I were to define this function, say f of theta, this relationship then that outputs our dependent variable is the vertical distance above the horizontal diameter as a fraction of the radius length. Some of you know it. What is it called? This is what sine is. S-I-N. It's not a bad thing, right? It's not a sin. It means sine. Sine, which is that whole expression right there, is this output value we're talking about. So when you see sine of theta, that whole thing together means one of the y values on this graph, or the vertical distance as a fraction of the radius length. Okay, it's not defined relative to a triangle. So some of you remember SOHCAHTOA, opposite, adjacent, hypotenuse. That comes later, okay? That comes from this. This is how we define sine. Sine is defined as, sine of an angle is all this estimating we were doing. The vertical distance above the horizontal diameter as a fraction of the radius. Some of you have had trig before, and this is news to you, okay? That's good. That's what sine means. So here's the beauty of this. Now suppose we have this actual fan, and what was the radius of that fan? 2.6 feet. Is that right? So now, suppose we want to do the vertical distance above the horizontal diameter in feet for this fan, which has a radius of 2.6 feet. What's the maximum number of feet? 2.6. And where does that occur? At what angle? I'll do this in red. So all the stuff about the fan, I'll write in red, okay? So then this scale becomes, when we get to the top of the circle, how many feet are we up? 2.6. And then going around, where's the lowest the fan or the bug will reach? Negative 2.6. And then when we're at 0.5 of a radius length, whenever the bug passes 0.5 radius lengths above the horizontal diameter, how many feet is it above? Not enough people, right? So whenever the bug passes a half a radius length above the horizontal diameter, how many feet is it above the horizontal diameter? 1.3 or 2.6 times a half, right? And whenever it's negative a half radius length or a half radius length below, then what's its coordinate in feet? Negative 1.3. So if my g, say I make a function g of theta, and let's say capital F for fan. And now I want the output to be feet, okay? So now the input's still the angle measure swept counterclockwise from 3 o'clock, but I want the output to be feet. What function will give us the number of feet that the bug is above the horizontal diameter? If sine theta gives us a fraction of a radius length, how would I create a rule to give me number of feet? Okay, do it with your partner. Do it with the person next to you. So now I want the output to be the number of feet. If sine theta is the fraction of radius length, how would I compute the number of feet above? Talk to the person next to you. Okay, so it should feel pretty easy. Sine theta is always giving me the right fraction of the radius length, and my radius is 2.6 feet. So to get the number of feet, I'm just going to do what? I just always want that fraction of 2.6. So, Pam, what would it be? This is a fraction of the radius length, right? This is whatever fraction of the radius length I'm at, and my radius is 2.6. So think of these as numbers like 1/3 of a radius length, 4/5 of a radius length, half of a radius length. And I want to apply that fraction to 2.6. So what calculation would I do? I would just multiply, right? I'm going to take that fraction of 2.6. And that's going to give me now the height in feet. Before, when the height was 1, now I want it to be 2.6. If the height was a half, I want it to be 1.3. If it's negative 1, I want it to be negative 2.6. Okay, anybody have a question? So it'll look the same, it's just that now it will reach up to 2.6 rather than 1 and down to negative 2.6. So we're going to have all those same fractions of 2.6 to get it in feet instead of fraction of a radius length. Okay, so let's do this for the horizontal distance. We'll go faster. So now, any questions? Can I erase? So now I want to do horizontal distance to the right of the vertical diameter. Okay, you guys are going to do it. Ready? So you're going to ask these same questions. Now we're looking at vertical distance to the right. First quadrant. You're first going to ask, does the horizontal distance itself, does it increase or decrease, and from what to what? Does it increase or decrease, and from what to what? That horizontal distance. And then you ask the changes, are they positive or negative? Getting more or less positive or negative. Go, talk. First quadrant.
There you go. There we go. Yes,
Okay, so the output, just the horizontal distance itself, is that increasing or decreasing, and from what to what? Decreasing from 1 to 0. Do you see that? It starts, the horizontal distance now starts not at 0 but at 1, and that's going to decrease from 1 to 0. So if it's decreasing, then are the changes positive or negative? A couple of people are saying negative. Agree with that? Are these negative changes? Yeah, the changes are to the left, right? Each change is to the left. So that's a negative change. Getting more or less negative? More negative. Changes that get more negative are increasing. Are these changes increasing or decreasing? Decreasing, getting more negative, starting from 1 to 0. So this last one was easier because we were looking at vertical distance, and that's what the y-axis shows, vertical distance. But now we're going to take horizontal distance on the circle and put it on the vertical axis. So this is not as friendly, right? This isn't, can't just look across and see exactly where the bug is up and down, because we're measuring now where the bug is left and right, and we're putting that value on a vertical axis. So when the angle is 0, right here, our horizontal distance is 1. We start up here at 1. And you said, so as we go from 0 to pi over 2, that distance will decrease from 1 to 0. So again, we're taking horizontal distance and we're representing it on a vertical axis. So this vertical axis now is horizontal distance right of the vertical diameter. Horizontal distance right of the vertical diameter. And that starts by decreasing from 1 to 0. So this graph goes down. And those changes, you said, get more negative, right? Each change gets more negative. Second quadrant. Horizontal distance, increase or decrease? Horizontal distance, does it increase or decrease in the second quadrant? Decreases from 0 to -1. As the angle increases from pi over 2 to pi, the horizontal distance decreases from 0 to -1. Do you see that? And the changes are positive or negative? Negative changes getting less negative. The changes are to the left, but they're getting smaller and smaller to the left. Increasing or decreasing changes? That's increasing negative changes. Third quadrant. As the angle increases from pi to 3 pi over 2, the horizontal distance changes from what to what? -1 to 0. Do you see it? Here the horizontal distance is -1, and as the angle changes to 3 pi over 2, that horizontal distance increases from -1 to 0. And then finally, the horizontal distance continues to increase from 0 to 1. Here the horizontal distance is 0. So we're not to the left or the right of the vertical diameter. Increases from 0 to 1. So at the top of the circle, the horizontal distance is 0. That's why the y-coordinate of this point is 0, because it's not to the left or the right. And then at pi, the horizontal distance is -1. It's the least it can be. That horizontal distance is -1. So here's that point, pi, -1. And then when it goes to the bottom of the circle, that horizontal distance then increases from -1 to 0. So when it goes through the third quadrant, the horizontal distance it's the least it can be -1, and then it moves to 0 horizontal distance at the bottom. And then when we get back to 2 pi, the horizontal distance is 1 again. That's why you have this point 2 pi comma 1. All right, so this then is the same as before. So we'll call this G. For any circle, if the input is the angle swept counterclockwise in radians, and the output is horizontal distance to the right of the vertical diameter, measured as a fraction of the radius, that's what cosine theta is. And if we wanted the bug in feet, how many feet the bug was horizontally, then you're just going to multiply that again by 2.6, taking every fraction of 2.6 that the cosine is. So that'd be feet.
Mr. Ashburn?
Yes, sir.
Today, could I actually not take the quiz today, sir?
What's that?
Could I perhaps not take the quiz today, sir?
No, why?
Because I'm honestly still struggling a lot with these concepts, sir.
Okay, well, the quiz was posted last Wednesday.
I know, but
yeah.
I still can't understand what I'm actually doing.
Yeah, so that's why you're going to get help Thursday and Friday, so you have to take it today. So that's why the quiz is posted ahead of time, and then you got 2 days, then Thursday and Friday to get help. So it's time to take it today. Sorry.
I was wondering if last class you found sunglasses here.
I didn't find them. Sometimes you could see if there's a department office close by, and there might be a lost and found.
All right, thank you.
Yeah, like I know there's like the naval offices. Just look for any department offices.
Is it okay if I leave after I take my quiz and recitation? It's all what?
Again? Yeah.
Alright.
Okay.
Just trying to get help with one of the questions in the 171. And I don't think the guys on the other tutoring center answered me correctly.
Like how I have fun.
Do the same thing, I think. I mean, you could just, now you could start at the horizontal one. Where's the horizontal? Yeah, instead of doing the sine, since the horizontal is harder, start with 4.
Okay.
I think that'll be enough. How did it go on Friday?
Alright, they were able to figure out the graphs
Oh, good.
on their own.
Yeah, but was that,
Yeah.
did they really do that through this way of thinking, or did they just know what it looked like and just go like
They
this?
had difficulty understanding the previous question.
Yeah.